Welcome everybody. This video is aimed to give you an overview of what the theoretical group at the Energy Materials Laboratory does. The theoretical and the experimental, both groups are working either together or independently, but most of the time we try to work in collaboration. The aim of the experimental and the theoretical group is to study materials, and to study these materials we need to actually predict the properties of these materials. Okay, so the properties of the materials is the aim, because knowing these properties of the material will then help you analyze the best material that you're gonna employ for your intended application, whether it's water splitting or carbon dioxide reduction or surface chemistry, whatever. So the properties is actually the basic thing that we're looking at for any material, and based on these properties we choose our material. So we can say that we both, the experimental and the theoretical group, we're both working on getting the properties of the materials. We have the theoretical group. The theoretical group, we use theory, we use physics theories like quantum mechanics, to predict the properties of the materials. On the other side, the experimental group, they work on getting the properties using spectroscopic techniques like XES. They want to get the topology of the surface, they use the scanning tunneling microscopy (STM) and infrared spectroscopy to get the vibrational properties of the materials. All of these properties that you can get experimentally, you can get using theory. After we get the properties of the materials, we then have our data. So these data are analyzed either by chemistry analysis. You can analyze it in material science. So you use either chemistry or material science in order to understand these data and utilize it. So both the theory and the experimental teams, they work on the analysis of these data. So the analysis is basically theoretical chemistry or theoretical material science. The difference is that the theoretical team, they work on getting the properties of the materials using theoretical methods, but we both share the theoretical analysis. So theoretical analysis is the scientific part of the paper that you have to add after getting the properties correctly. So again, the aim of the EML, we both share the same aim, which is getting the properties of the specified materials. The theoretical group, our theoretical group, we use theoretical methods, and theoretical methods actually involves physics or quantum mechanics calculations. And the advantage that the theoretical group has over the experimental group is that theoretically you can get all the properties of the material. This is because actually the theoretical method is based on just getting the electronic structure of the materials correctly. And if you have the electronic structure of the materials correctly, now you can predict all the properties of the material, because all the properties of the material, of any material, is entirely dependent on the electronic structure. So basically, once you get the electronic structure correctly, you can get the band structure, you can get the conductivity of the material, you can get the infrared spectrum, you can get everything after getting the electronic structure, because the electronic behavior is what governs the material's properties. Okay, and there's a very important note that you have to know, that the electronic structure of each material is very unique. There is no similar electronic structure of two different materials, and that's what varies from one material to another. Okay, so that's why knowing the electronic structure will give you the properties of the material, because the electronic structure is unique for each material. Okay, so how can we get the electronic structure theoretically? By knowing the behavior of the electrons, how the electrons behave. And by the behavior, I mean the potential energy that these electrons are feeling and the kinetic energy of these electrons. And we just put molecules or the nuclei themselves as static particles, static charges, ionic charges that are present, and the properties are only governed by the potential energy of the electrons and the kinetic energy of the electrons. Okay, so in order to describe electrons, we can use quantum mechanics. Why specifically quantum mechanics? Because quantum mechanics is actually what describes electrons most accurately, because classical mechanics will not describe electrons accurately or even close to accurate, because electrons are actually waves. Okay, so and quantum mechanics is actually based on wave mechanics, so it deals with electrons as waves. So this is basically what the theoretical group do. It just predict the properties of the material by getting the electronic structure. How can we get the electronic structure? By knowing the total energy of the system, which is the potential and the total energy. How can we derive those energies? Which is using quantum mechanics by solving the Schrödinger equation. Solving the Schrödinger equation will give you the energy, and once you have the energy, you have all the information you need to know about your system. However, the quantum mechanics isn't that easy or to solve, and it's not that simple. Actually, there are many approximations, and these approximations lead to having approximate calculations. And these approximations actually are not very reliable in some cases, and we need experimental data in order to test if our data is reliable enough or not. And also, as we just said, that quantum mechanical calculations are pretty complex to apply. But however, there are many advantages of the quantum mechanical or theoretical methods for getting the properties. One of these advantages is that certain properties are not accessible experimentally. Each university or each group within each university has certain capabilities, certain experimental techniques or tools, and these tools maybe they're not enough to get all the properties that you need to get. So as we just said, that all the properties are known by knowing the electronic structure. Thus, theoretically, we have the advantage of getting all the information that we need to know about the material that we're dealing with. So this is a very important advantage that you need to know about. Another thing is that we can also get theoretical information about new materials. We can just play with the materials. We can add new atoms to the material, to the bulk or to the surface of the material, and test what's going to happen. So this is important because it saves money for preparing the materials and the samples, and the energy and time that you'll need in order to produce these samples. But theoretically, you can do this over your computer and get the data about these new materials. If these data are desirable, then you can go to the lab and manufacture this material and test it experimentally. But this is a very important advantage to have, that you can exceed the limits of the experimental tools that you have. So this is entirely the overview of what the theoretical group at the Energy Materials Laboratory does. Maybe I think that you're wondering what is DFT, because maybe that we always link the theoretical group to DFT. Actually, I'll give just a hint about DFT. Quantum mechanics, we said, is the science that we're using in order to predict the properties of the material. One of the most convenient and cheap, computationally cheap theories is the density functional theory. And the density functional theory is actually very, very, very clever, because scientists Kohn and Sham, they worked on a very clever idea, saying that the density, they found that the density, and they proved it, the density of electrons inside each material is unique. And they linked this uniqueness of the density of electrons with the uniqueness of the electronic structure of each material. So this link through the Kohn and Sham orbitals that they have used instead of the wave functions, the actual wave functions of the electrons inside the system, made that link accessible and made it rational. And through this link of the unique densities of electrons and the unique electronic structures, we can get the electronic structures by knowing the density of the electrons. This is a very simple idea. Instead of solving for many electron systems, we just use the density of the electrons present in the system, which is unique for each system, and then get the electronic structure, and from the electronic structure we can then know all the properties. And this is what basically the density function theory is. And this is an overview of what the theoretical group actually does.